Hello and welcome back to the game development series of video tutorials. In this video I'll be showing you how to create the camera class, and the camera class will be used to navigate your position of the eye through a 3D world. So the camera is going to determine where you're located in 3D space and in which direction you're looking. Using this information, we can then navigate through our scenes and have either a third-person view game or a first-person view game. So if you enjoy my tutorials and you would like to support my website, please go to www.maticnose.com and click on the PayPal icon, or click on any of the links from the Google Ads which are posted on the side of my website. Now let's go into Visual Studio and start creating that camera class. What we first need to do is create a .h file and a .cpp file. So we'll go in here and select our game engine, click New. We want to create a new, we'll call it Camera, and I'm going to go put it into the, let's see, it seemed to make more sense if we put the camera into the scene, since the camera navigates through the scene. So that's where I'm going to put it. Camera. Oh. Open camera scene. Okay. And we need to create a .h file as well. Okay, and put that into the scene, and we'll just double check to make sure. Okay, it's located in the scene as well. So let's begin with the .h file. At the top we have we include our vector3.h, which is should be located in the mass, I do believe. Yeah, it's right here. And we have our class definition. So we have a constructor and a virtual destructor. We then have a function call for set, and we use this to set the initial location of our camera, so in the X, Y, and Z. We have a function called move, which moves the camera along a specific direction for a specific amount of time. Now, you'll notice that the code for the camera works based on time, and the reason for this is if you have a slow computer and you run this code and then compare it to a fast computer that runs this code, we want to be able to move through the 3D scene at the same rate, independent of how fast the computer is running. So because of that, we need to know the time that the program is executing at, so that we can scale all our movement based on each time interval. We then have three function calls here to return the X, Y, and Z coordinate values of our camera position, and we also have get angle Y, which is the angle in degrees that our camera is currently pointing in. So it's kind of like the direction angle. Then our member variables, we have a vector that contains our position. We have a floating point number which contains our angle. This is the rotation about the Y. We have two scalar values here which define how quickly are we able to move through the scene. So we control the speed in a linear fashion, so how quickly can we step forward, left, and up and down. As well as we have an angular speed here, which determines how quickly we can turn in the scene. And you'll see how we use those in a minute. And then we have three vectors here. There's a vector for direction, and there's a vector here for the side. So what this means is the look direction determines which way we're looking in the 3D scene. The side direction tells us which direction is exactly to the right or to the left of us. So these two vectors here should always be perpendicular to one another. And then we have another vector here called look direction home, and what this is sort of the home position, or actually it's the initial direction that we're looking in. And you'll see why I do this when we look in the constructor in a minute, but it's basically to prevent round off errors. Okay, so that's the .h file, and before we go into the CPP, well, actually no, let's go into the CPP. I'll define everything in the class, and then we'll go back and actually show you how to put it into the OpenGL code. So to begin, we always start with the constructor here. But before we talk about that, let's just take a look at the includes here. We include our predefined headers as well as the camera.h file. And you'll also notice here I'm including core.h. Now, the reason for this is a little bit later on. You'll see I'll need an enumeration which is going to be stored in core.h, so I just put it up here right now. Okay, the camera constructor. First thing we need to do is initialize all of our member parameters. And so if we go into here for camera, we see we have our angular speed and linear speed. So we set those to be some values here, 30 and 25. And these determine how quickly we can move in the scene. So again, linear speed is the amount of units per second we'll be able to move. So if we move the camera for 1 second, it's going to move 30 units in our 3D world. If we rotate for 1 second, we're going to be rotating 25 radians, which is actually quite a bit. Then we have, what other things we have? We have FRY, which is the angle we're currently looking at. So initially we're just going to set that to 0. And then we have a vector for look direction home, and then side direction and position. So our position initially is going to be 0, 0, 0. So the camera's initially located at the origin of the 3D world. And then our look direction, we initially are looking down the Z coordinate or Z axis. So we have 0, 0, -1. Now it's very important that this vector here is a unit vector, which means it's length 1. So you see here it is length 1 and it's just pointing in the negative direction along the Z. And then we have direction home. Direction home is always just going to be equal to this value. So it's never going to change. So that's why I'm setting it to be whatever the initial value was. The last thing here is side direction, and we call our set perpendicular xz, which was located in our vector class. If we go here, set perpendicular xz, you see we use that little trick here for changing our 3D vector to be perpendicular. You see here, we use that little trick. We're taking the vector here, which again, we're passing in the look direction. So we want to make this vector perpendicular to this one. So that's what this function does. It's taking in our look direction and taking the perpendicular values of it and setting them to be equal to the side direction here. Next thing we have our Destructor, and it doesn't do anything, so it's just blank. We have our set function call, so this moves the camera to a specific location in the XYZ coordinate frame. So we pass in XYZ and we just create a vector using those 3 values, and we set that equal to the position of the camera. Okay, the next function is called move, and the way it works is it defines in which direction we want to move, and then it calculates the new position of the camera. But to use it, we need to create an enumeration, and as I was saying before, in the core I'm going to place that enumeration. So let's go into the core.h, and just on the bottom here, underneath graphics render, I'm putting this enumeration. I call movement. And I give it 6 different values, so I can either move forward, I can move back, move left, move right, or I can turn left or turn right. Again, if you want to add more different kinds of movements here, you can just add them into the enumeration. So now we can go and define our move class. Actually, before we add the next function for move, I think the constructor here was, or the function call for move was incorrect. Yeah. In the core here, we've defined this enumeration called movement. So in the camera.h, we should be using that movement here, movement, and I'll call it direction. And again, because we're using movement, we should actually move this around a bit. So instead of putting the core here, we're going to put it inside here since that's where it's needed. Okay, now we can go and add the movement function. Okay, so we're passing in the direction we're moving in and the amount of time that has elapsed. So we're going to use this amount of time to determine the new location that we've moved to. So if we're moving forward, then we take the current position and we subtract our current look direction by scaled by this value here. So the amount of time that has elapsed times the speed that we're moving at is the distance, and then we take that distance and we multiply it by the look direction. So it's important here that the look direction is a unit vector, so that then this overall value is the number that we move our current position in. And so that's moving forward. Moving backward is exactly the same thing, but instead of a minus here we have a plus. And then for the left and the right movement, instead of using the look direction, we use the side direction. So that's why we needed to know the perpendicular direction with respect to the look. So the look direction points straight ahead and the side direction points to the side, left and right. And again, left is positive, right is negative. You can play around with these. If you swap the plus and minus signs, you'll notice that as you press one arrow key, then you'll be moving in the wrong direction and things like that. Turn left and turn right. Here you see what we're doing is we take the value for the amount that we want to move. So for instance, the time it takes to turn as well as the speed that we're turning. So the result of this multiplication gives us the amount in radians that we have turned, and then we offset that the stored value in our member variable for our angle that we've rotated by this offset value. So here we're subtracting if we're going to the left, and here we're adding if we're going to the right. And then what we do is we take the look direction. We have to calculate a new look direction. And the way we calculate the look direction is we take the original home position for our direction and we rotate it about the y-axis by this value here that we calculated. Now, there is another way to do this, and the other way to do it would be just to take our look direction and constantly update it by the amount that we want to rotate. By doing this, you'll cause numerical problems, because as we're rotating over smaller and smaller values, the compiler will start rounding things off, and the look direction may no longer be a unit vector after a lot of rotations. So to prevent that, that's why we have this home look direction here. So anytime we go and rotate, we take the home direction and we rotate it by the value we want to rotate, rather than doing an incremental rotation. So this gives us a new look direction, and then based on the new look direction, we also have to calculate the new side direction, because every time we change the look direction, we have to change the side direction, or else our coordinates wouldn't match. And the same thing happens for when we turn left. The only difference being is that the value here that we're turning is negative and positive for the right. And finally, at the bottom, we just have a bunch of get function calls. So we have getX, which returns the camera position's x coordinate, getY, which gets the y coordinate, Z, which gets the Z coordinate, and lastly, get the angle for the Y. So in other words, what is the turning angle that our camera is rotated by? And internally, we use everything in radians, but OpenGL needs a value in degrees, so we have to take that rotation angle in radians and convert it to degrees. Now you'll notice here that I'm using a constant here called pi, but we need to define this constant pi. And by the looks of it, it's already defined for us. So let's go and see if we can complete this. Gave us some error messages. Okay, we notice here that we're missing cos and sine, as well as we're missing the declaration for pi. So It's kind of peculiar that when I highlight this, it tells me what pi is, but then it tells me that pi is undeclared. Well, that's alright, we'll define it in a second. Well, first thing though, to identify the sine and cos function calls, and to do that we can go into our precompiled header, which is located in our main, and at the bottom here we can include math.h, and that will have the sine and cos values. And then for our pi, we can go into the core.h here, and just underneath the safe delete here, we're going to define pi, and I just set it to be 3.14159265358979323. You can set it to something shorter if you like, but that's my choosing for pi. Okay, so let's see if we can compile the camera now. Before we try to compile the camera, we need to recompile the standard precompiled headers. Okay, now let's try compiling the camera. Okay, it seems to be okay now. So we can go into the OpenGL code now and actually add the camera into it as well, since right now we've just defined the class but we haven't chosen to use it anywhere. So inside the OpenGL header file here for the game, we want to include a member for the camera. So camera, and I'll just call it m_camera. For us to be able to use that, we need to go to the top here and include camera.h, like this, and we need to go into the constructor and define how we operate that camera. Oh, not camera.cpp, but this guy. Okay. So in the constructor, we're going to take our camera value and we're just going to set it to be 0, minus 0.1, and 0. Now, if we go down into, where was that? Render pre, I think. Render pre. Yeah, we see here what we did here is we offset the camera by minus 0.1 and then minus 1. So instead of doing this, let me just comment this out like this, and we'll go back to the constructor here and we see now we do the same thing up here by setting the camera. So 0, minus 0.1, and then minus 1.0f. So what that does is it's going to take our camera, it's going to move the camera eye up 0.1, and it's going to move it away from the scene by 0.1. Now you'll notice here that everything is in a negative direction because the way that the camera works in OpenGL is we don't actually have a virtual camera in OpenGL. We have to physically move the scene in the opposite direction. So if we want to move above the scene by 0.1, we actually have to move the scene down by 0.1. So that's why we have this negative sign here. Okay, so the camera has been initialized, and then in the render pre, we can now add the camera control into here as well. So what we do is we first take our camera and we rotate it about the y-axis by the value that we return back here from the camera. So initially it should be 0 because the camera hasn't rotated. So we'll take 0 and we rotate it about 0, 1, 0, which is the y-axis. And then after we rotate the camera, we then go and move it. So to move it, we call GL translate F, and we move it by the X, the Y, and the Z value. So you see here we're now using all these functions which we created in the camera class. So that's the way we implement the camera, and everything seemed to build. But you'll notice that when we run it, if we press the arrow keys, still there's nothing that's happening. But we can notice that the camera is actually working by playing around with different things here. We can go into, for instance, the camera. Well, instead of playing around with the camera, let's go into here. Instead of specifying a 0 angle here, let's say we want to rotate the camera by, I don't know, 30 degrees. If we do this, then we should see that the scene is slightly rotated. So now we're looking a little bit 30 degrees to the right. And if we go and change this to -30, then we'll see that we've rotated the camera to the left by 30 degrees, and we're looking at the other triangle here. So in the next tutorial, what we're going to be doing is we're going to be taking this camera class and actually updating it based on the keyboard presses that we do on the keyboard. So as we press the arrow keys, we're going to be updating the camera position as well as the camera angle, so that when the code runs through here for the render pre, it updates the camera and then it renders everything correctly. Alright, so that's the general structure. Come back for the next tutorial to see how to finally add the keyboard handling.